Question 17. Healthy human blood needs to be maintained at a pH of 7.4 for the body to function normally. A star. Carbonic acid, H2CO3, is a weak acid which, together with hydrogen carbonate ion, HCO3-, act as a buffer solution to maintain the pH of blood. The pKa value for the dissociation of carbonic acid is 6.38. Explain in terms of equilibrium how the carbonic acid hydrogen carbonate mixture acts as a buffer in the control of blood pH, and calculate the concentration of hydrogen carbonate ion to concentration of carbonic acid ratio in healthy blood. This is carbonic acid. When it dissociates, you form hydrogen plus hydrogen carbonated ion. This is what we call buffer solution. You have large quantity of the salt. This is what we call the conjugate base for this conjugate acid. So conjugate acid base pair, and so you have a large concentration of the acid, and you have a large concentration of the base, and this is a small value of H+. So this buffer solution will resist change to pH upon addition of small amount of hydrogen or small amount of hydrogen proton, or smaller amount of acid or small amount of base ion. If we add H+, the equilibrium, this equilibrium, will shift to the left because the H+ we added will be removed by the salt, which will then produce more of the acid, because that plus that will produce more of the acid, hence shift equilibrium to the left. And if we add OH ion, the base, the equilibrium will shift to the right, because OH ion will react with H+, forming water, and then there's less of H+, which means this acid will not dissociate to produce more H+. So here I've written out the equilibrium constant equation, and you've got the concentration of acid and the concentration of the salt divided by the concentration of the acid, carbonic acid. So then in order to get the ratio, in order to find the ratio of the hydrogen carbonate ion to carbonic acid, so we want the ratio of hydrogen carbonate ion to carbonic acid, which means I need to divide both sides by the concentration of the proton. So divided by concentration of proton, you have to divide that by concentration of proton. That will cancel out the concentration of proton. Hence, you're going to have Ka over concentration of proton equals concentration of the salt over concentration of the acid. Now we know the value of Ka. We're using Ka equals 10 to the power minus pKa, which is that, and we're going to write that here. So that's that, and we know the H+. The H+ is equal to 10 to the power minus pH, which is that, because we're given the pH, also we're given the pKa. So that is what we put at the bottom here, and that ratio gives that, which is equal to that ratio, which is that. And therefore, so the ratio of the salt to the salt or the base to the acid is 10.5. B. Red blood cells contain hemoglobin. Explain using ligand substitutions how hemoglobin transports oxygen around the body, why carbon monoxide is toxic. Iron 2+ in the center of hemoglobin binds to O2. O2 forms a dative covalent bond to iron 2+. Lost O2, when O2 is released from iron 2+, it is replaced by water or carbon dioxide or carbon monoxide ligand. For carbon monoxide, the CO form stronger dative covalent bond. That means it binds strongly to iron, harder to break. The CO bond lone pair on the carbon forms dative covalent bond to iron 2+. This bond is much stronger than the bond of oxygen gas to iron 2+. So when that bond happens to iron 2+, it is impossible for the hemoglobin to bond to oxygen to carry oxygen around the body. So therefore, the body will be short of oxygen, which can lead to death.